So today we're talking about experimental design and observational studies, and it is literally me talking. There's not a lot to this video, so the investigation's a tad more helpful, but I'll talk about a few things. Okay, so first off, we have an observational study and an experiment. The two things that are different here: an observational study, we're just watching. We have no impact on the variables. In an experiment, we do have an impact on the variables. So we change or manipulate a variable. And this is what we call imposing a treatment. Now, so something that came up on one of the examples was a test of memory and reaction time. And they took a group of people of a certain age and tested their memory and reaction time. The fact that they gave them that test didn't change their memory or their reaction time. It simply recorded or measured their memory and reaction time. So if they're doing something to the subject, it might be an experiment. If they're not doing anything to the subject, it's an observational study. Now, then if the answer is yes here, you need to ask this question. Is that something being used to change how they react or to measure the reaction? So if this is change how they react, then it's an experiment. If it's just to measure the response, then it is an observational study. So the difference there, say we're doing something on weight loss. If we are giving a group of subjects a diet pill, we are changing how they react. That's an experiment. If we are just weighing them, and we're measuring that response, that's just an observational study. So hopefully that clears it up, or at least doesn't make it worse. Now, the next part, we're just going to go over some definitions that are not in order. That's very helpful. So we'll go a little bit out of order. All right. We have, in each of these cases, explanatory variables and response variables. In an experiment, those are the variables that are getting manipulated. In an observational study, it's what we're observing, but what we think is making the difference. And the response variable is how we measure that difference or outcome. So let's come back up here. In an observational study, the subjects are identified and then watched. No change to a variable. We have prospective observational studies where we look at past records. I just said the wrong thing. We have retrospective studies where we look at past records that already exist. And they're prospective, where we decide who we're going to watch and we watch their future behavior. This can be done over decades of time, prospective studies or retrospective for that matter. Like if we want to know how effective Head Start programs are for preschoolers, they would identify these kids when they're going into Head Start, and then they watch them for decades to see how they do in school and how they do after high school and so on and so forth. The subjects are the individuals being studied. Often these are people. They don't always have to be people, though. It's just what we're studying. It could be animals. It could be products, if we're just picking out products to see if they're defective or not. could be just the products. In an experiment, a treatment is imposed. So that treatment, what we're looking at is the changing of a variable. And the treatment and the factor, so the factor is an explanatory variable and the treatment is the possible combination of those factors. And the best way that I can do this is to kind of shrink this up and show you a little bit of a diagram. So let's say I want to do an experiment on diet and exercise to determine what results in the best amount of weight loss. So I might have hang on. So I have diet and exercise. So those are two of my factors. Those are two explanatory variables in this experiment. And let's say I have two different diets. I have a vegan diet and I have a low carb diet. And actually, I probably want to do a third that is just a regular omnivorous diet, whatever you want to call it. So these are all levels of this factor. Vegan, regular, and low carb. I have 3 levels of the diet factor. All right, so then let's say I have 2 exercise regimens that I'm going to randomly assign to people in each of those diet groups. So I have a 30 minutes of cardio, and I have a no exercise for a control. My group that doesn't do anything. So I'm going to call these A and B because I don't want to write that again. These are also levels of the exercise factor. So with each of those, I'm going to have a treatment. I'll have one group of subjects that does a vegan diet and 30 minutes of cardio a day. Whoops. So we'll call that, these are all the treatments. So this will be VA. This one will be vegan diet and no exercise, VB. This will be a regular and 30 minutes of cardio. Be a regular diet and no exercise. This right here is my control group that I'm not doing anything with. Regular diet, no exercise. Low carb, exercise A, the 30 minutes of cardio, and then I've got low carb, exercise B. So I have 6 different treatments that are the combinations of the levels of each factor. So 2 factors, 3 levels of the diet factor, 2 levels of the exercise factor result in 6 total treatments. So that may be a little bit more than we need for Algebra 3-4. I really, to be honest, don't know. But hopefully it helped explain some of those. The last little bit here, placebo, I forgot to talk about that one, is a fake treatment that looks like the real treatment. Often that's a pill, but it doesn't have to be. It can be an ointment. It can be like a medical treatment that you think is happening but isn't really happening. Because oftentimes people think that something is having an effect just because they know something's being done. So that is a lot of just vocabulary and explaining on experiments and studies. Again, hopefully it helped. It's not a very exciting video, but we'll see you next time.